So this is numbers 13 through 18 on the study guide. Still factoring here. I want to start with the GCF. This does not have a GCF, but I do see I have a difference of 2 squares. So I'm going to open up 2 parentheses here. 36x squared. So 6x times 6x would give me 36x squared. And then 5 times 5 would give me 25, where I make one positive and one a negative, and that was how we would get rid of our middle terms, so this would be our final answer. On this one, this is a trick question, and what you need to do is take that a squared, then put minus 10a, and then plus 25, because remember the constant should always be at the end. So now if we do a factor x here, we have 25 here and a negative 10 here, so negative 5 times negative 5 is positive 25. Negative 5 plus negative 5 is negative 10. So really this would be a minus 5 times a minus 5, but we should write that differently because it's the same thing times itself, so there's 2 of them. So a minus 5 squared. On number 15, hopefully you crossed out that last little term, otherwise that would have made this prime. We've got our factor x here. 36 goes here, 12 goes here. So 6 times 6 is 36. 6 plus 6 is 12. So this would be like x plus 6 times x plus 6. Again, that's the same thing times itself. So we have x plus 6 squared should be our final answer. Alright, so number 16, it says we're supposed to solve by factoring. So again, the first thing we want to do is take out a GCF here. So the GCF that I see they both have, or they all have, would be an x. So x times x squared plus 24x plus 144 is going to equal 0. This I see is a trinomial, so we want to see if this is factorable. So we'll put 144 up here and 24 down here. Well, 12 times 12 is 144. 12 plus 12 is 24. Don't forget this GCF, bring it down. And then that would be times x plus 12 times x plus 12, and that would equal 0. Well, remember the zero product property, which means that if any one of these we can get equal to 0, any of the factors we can get equal to 0, the whole thing will equal 0. So if I take this x and I say set it equal to 0, it makes sense, because if I put a 0 in here, 0 times all of this will equal 0. So that's one of the answers. But another one I want to look at is this x plus 12 and set that equal to 0. If I subtract 12 from both sides, then I get that x is equal to negative 12. If I put a negative 12 in here, that would make this factor equal to 0, or even this one, so the whole thing would equal 0. So the two answers to this problem would be 0 and negative 12. On the next one, I see that the leading coefficient is something other than 1, so 3 times negative 8 would be negative 24. And then we want a negative 2 here. So we want to think of the two numbers. That would be 6 and 4. And so the 6 would have to be negative. So now we're going to factor by grouping. So we have 3x squared minus 6x would be the first group, plus, this would give me 4x minus 8 would be the second group. So the GCF I can pull out of both of these would be a 3x. 3x times x minus 2 would give me that one. And the GCF out of here would be 4, so 4 times x minus 2. So the two factors I get are 3x plus 4, and then I get x minus 2, and those should equal 0. So now let's set these equal. 3x plus 4 equals 0, and x minus 2 equals 0. So if I subtract 4 from both sides, I get that 3x equals negative 4. Divide both sides by 3, and x is going to be negative 4/3. If I add 2 to both sides here, then I get that x is equal to 2. So we know x is 2 and x is negative 4/3 to be the two answers for this problem. On this final problem here, we've got that we have a 2 here and a negative 3 here. If I did negative 1 times negative 2, I would get positive 2, added together negative 3. So I have x minus 1 times x minus 2 equals 0. And so I want to set both of these equal to 0 and solve. If I add 1 to both sides, x equals 1. If I add 2 to both sides, x equals 2. So x equals either 1 or 2, or actually it equals both 1 and 2.